Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing question, answer and explanation of a state of matter, particularly gaseous state. Now I will continue. Question number 59 I am reading. When with increase in temperature, the difference between RMS velocity and average velocity will, first option, increase, second option, decrease, third option remains same, fourth option decrease, becoming almost zero at high temperature. Now again I am repeating. With increase in temperature, the difference between RMS velocity and average velocity will, first option, increase, second option, decrease, third option, remain the same, fourth option, decrease, becoming almost zero at high temperature. Just to think, this is a very conceptual question, and all questions whatever I am discussing are important for medical and engineering examination. Just to think. Now I am telling the answer and explanation. Its correct answer is increase. Difference between RMS velocity and average velocity will increase. Correct? First option is correct. Why? Now I am telling you. Question you have to read carefully, then only you can answer. Okay. Here that U means RMS velocity, that is equal to under root 3T. Already I have just told this expression for all three type of velocity. That is the RMS velocity is equal to under root 3RT divided by M. And this average velocity is equal to under root 8RT pi m. 8RT pi m. Then just to compare both, RMS velocity is equal to under root 3RT divided by m, and for average velocity it is under root 8RT pi m. Then see, T is in both, temperature is in both expression, and both are in a numerator it is there upside. Then that is the 3T you can tell. U is equal to under root 3T, and V means average, that is under root 8T. Correct? Hence with increase in temperature, if temperature will increase, the difference between U and V will increase, because both are seen. U is related to temperature under root 3T and average is under root 8T. Then if we will increase the temperature, then velocity will increase, velocity will increase because that depends upon the temperature. Then because when the temperature will increase, both velocity will increase. Hence difference there will be, you can say, increase. The difference between u and v will increase. Correct? Now next question I am reading. That is question number 60. At high pressure, the compressibility factor Z is equal to, first option unity, second 1 minus PV upon RT, and third option 1 plus PV upon RT, and fourth option 0. Again I am reading the question. At high pressure, the compressibility factor Z is equal to, first option unity, second option 1 minus PV upon RT, third option 1 plus PV upon RT, fourth option 0. Just to think, this is a direct question answer you can tell. If you are knowing the condition, then according to the condition relations are given. Hence if you are understanding the concept and the relation, quickly you can answer. Just to think. Its correct answer is 1 upon PV up P1 plus PV upon RT. 1 plus PV upon RT. This is the correct. This is the correct answer. And now I am giving you explanation. P plus A upon B square into V minus B, that is equal to RT. You know, for the real gases. This is the expression for real gases. P plus A upon B square in bracket into V minus B in other bracket, that is equal to RT. Then at high pressure, B cannot be neglected. At high pressure, B, that is the co-volume. At high pressure, B cannot be neglected in comparison to V, volume V, and B is the volume for the gaseous molecules, only for molecules, because there will be a gap between the molecules. Then total volume is V, and only volume of gaseous molecules, that is the B. Then at high pressure, because volume at high pressure volume will be less, but molecules volume will be as it is. But if the volume is very high, total volume, then in comparison to that, volume of gaseous molecules will be less. You can neglect it. If pressure is very low, then gas will, what will happen? If pressure is less, then volume will be more. If pressure is high, volume will be less. Then volume will be less, then gaseous molecules will be, therefore its volume will be as it is. That time at high pressure, that gaseous molecules volume, that is the B, a small b, can't be neglected. This is the important things. Then at high pressure, B cannot be neglected in comparison to V. Further, though V becomes small, A upon B square is large. A upon V square volume, and that is it is added in pressure. Even B is you can say B cannot be neglected in comparison to B. Then further, though B becomes a small, A upon B square value is large. But as P is very high, A upon B square can be neglected in comparison to P. Hence, what will happen? That P into B minus B, that is equal to RT, because with P plus A upon B square was there, that you can neglect. That A upon B square can be neglected, means only P you can write. Then P into B minus B, that is equal to RT. Then now just you have to rearrange it. Then what you will find? PB is equal to RT plus PB. Just you have to rearrange. P into B minus B. It means you remove the bracket, then PB minus PB, that is equal to RT. Then PB is equal to RT plus PB, because minus is there, right side it will come plus PB. Then after that, just to divide all by RT. Then PB upon RT is equal to RT upon RT, that will be cancelled. Then you will get only 1 plus PB upon RT. Hence Z is equal to what is there? 1 up plus PB upon RT. You know that PB is equal to constant into nRT. PB is equal to nRT. Correct? Then if you will take PB upon RT, that is equal to Z. PB, remember, PB upon RT, that is equal to Z. Then now you have seen PB upon RT is equal to 1 plus PB upon RT, and that is actually Z is equal to 1 plus PB upon RT. Hence correct answer is option C, 1 plus PB upon RT. Question is actually tough. This question is not easy. You have to do something. Okay. Then now next question I am reading. Question number 61. At lower temperature, all gases show, first option negative deviation, second option positive deviation, third option positive and negative deviation, fourth option none. Again I am reading the question. At lower temperature, all gases show negative deviation, second positive deviation, third positive and negative deviation, fourth none. Just to think, this is also conceptual, and you can, if concept is clear, easily you can answer it. Just to think. After that I will tell the answer and explanation. Now its correct option is negative deviation. Its correct option is negative deviation. Correct? How? Now I am telling you. At a lower temperature, is the condition actually when you will decrease the temperature, all gases show negative deviation. Okay, you should remember that it will affect the Z, PV upon, I have told you PV upon RT. Then when T is less, that time that it will show negative deviation. Okay, that actually is related to Z, and this, what is the Z? Z is compressibility factor, means how easily gas can be compressed. Okay, then for the compression, what is the condition? How easily you can compress, correct? Then for that this lower temperature will show, if temperature will be this less at lower temperature, then there will be negative deviation, and at high temperature positive deviation. Then now next question I am reading. Question, actually answer A is correct, option A, negative deviation. Now next question I am reading. 62. The ratio of most probable velocity alpha and average velocity, that is the V and V bar you can tell, and root mean square velocity U is, now 4 option is given. Again I am reading the question. The ratio of, actually you have to take the ratio of all three, simple way. The ratio of most probable velocity alpha, average velocity V bar, and root mean square velocity U is, first option, under root 2 is to under root 8 pi is to under root 3. Second option, 1 is to root 2 is to root 3. Third option, under root 2 is to under root 3 is to under root 8. Fourth option, 1 is to under root 8 pi is to under root 3. Again I am repeating the question. Listen carefully. The ratio of most probable velocity alpha, average velocity V bar, and root mean square velocity U is, first option, under root 2 is to under root 8 upon pi is to under root 3. Second, 1 is to under root 2 is to under root 3. Third option, under root 2 is to under root 3 is to under root 8. Fourth option, 1 is to under root 8 pi is to under root 3. Just to think. I think this is a little difficult, not very difficult. Just to think. If you will remember the all three expression, many times question is asked based on that expression. Then this question will be easy to solve. Just to think. Its correct option is first option, that is under root 2 is to under root 8 divided by pi is to under root 3. Correct? Now you should remember here that if you will solve it, all three expression, if you will solve it, then you will find that under root 2 is to under root 8 upon pi is to under root 3, because three expression already all three expression I have solved u. That is the u is equal to under root 3 RT upon m. Then root 3 is there, and average velocity is under root 8 RT upon pi m. Then here what is common, you neglect it. Then RT upon m is common, you neglect it. Then u is under root 3 and v is under root 8, and alpha, that is the RMS velocity, most probable velocity, that is the 2 RT, means under root 2. Then take only digit under root 2, that is the first velocity is under root 2, because 2 RT upon m, and RT upon m is common in all, just to don't consider. Then what is remaining? Then for alpha, under root 2. For this average, 8 upon pi, under root 8 upon pi, and u is equal to under root 3. Then now in question you can see ratio of most probable velocity, that is you have written in the beginning. Then for that under root 2 is coming, and for average velocity under root 8 upon pi is coming, and for root mean it is under root 3 is coming. Expression you remember, then easily many questions you can solve it. Then option A is correct. Under root 2, remember under root 2 means you are talking about most probable velocity, under root 2, and 8 upon pi, that expression is for average. At least 2 you remember, third automatically you will come to know. And average velocity is root 3. Correct? Now next question I am discussing, that is the last question of today's class. In case of hydrogen and helium, the van der Waals forces are: first option is strong, second option very strong, third option weak, fourth option very weak. Again I am reading the question. In case of hydrogen and helium, two gas you have to consider, helium and hydrogen gas. In case of hydrogen and helium, the van der Waals forces are: first option is strong, second option very strong, third option weak, fourth option very weak. Just you think. I think this is a theoretical concept is there. You can solve it. This is based on theoretical concept. Just to think. After that, I will give answer. Its correct answer is very weak. Among hydrogen gas and helium gas, van der Waals forces are, means already van der Waals forces is popular for weak only. That, but in this case, two gases, that is very weak. Van der Waals forces in case of hydrogen and helium is very, very weak. Okay. Van der Waals forces in case of H2 and helium molecules are very weak. Why? Being a small molecules. Its main reason is that gaseous molecules are very small. Correct? Due to that, forces are very weak. Today I am stopping only here. Next class again I will continue with another, you can say, another topic, that is the collision frequency and mean free path. Thank you.